Good afternoon, everyone, and welcome back to the ETP annual conference. My name is Stephen Mark Williams, Executive Director of ETP, in case you don't know that already. So fascinating presentation this morning from Chris Stark, and also a couple of good sessions there I was in. So this afternoon we have three, again, continuing our discussion around really energy systems, whole energy systems, what the future looks like. Three great speakers. We're going to kick off with Simon Gill in a minute, Head of Whole System Technology, Head of Whole System and Technical Policy at the Scottish Government. Who'll be talking about decarbonising the whole energy system. Seems quite a task. But just a couple of reminders. Again, apologies if you heard this before. The posters are still open. So on the right-hand side of the portal, if you want to go and look at them, there are 9 of them. Secondly, please do not press the back button if you want to get out. Go to the back to timeline kind of arrow on the top left-hand side. If you press the back button in your browser, you may leave. In fact, you probably will leave and you have to come back in again. And finally, at the end of all of these speakers, there'll be an opportunity to ask questions in a Q&A. So could you please use the discussion forum? There is a button on your toolbar at the bottom, and discussion forum, once you click that, you'll see all the questions and stuff on the right hand side. So I'm going to do that. Thank you, Natasha. Excellent. Glad you've been keeping track. So I've just typed hello. So if you could do that, just let me know that I'm not alone, that I'm not talking into the ether, because that's what I do at night. So during the day, I hope occasionally that people listen to me. So anyway, where are we? So we have Simon Gill, in fact, also used to be an academic researcher within Strathclyde, and clearly the government decided actually he was too clever to be left on his own devices and need to absorb him into their policy making unit. So here he is, Simon Gill, and welcome.
Thank you. Thanks, Stephen Mark. Hi, everyone, and thank you for the opportunity to speak today. As Stephen Mark said, my name's Simon Gill. I'm Head of Whole System and Technical Policy at Scottish Government, and I've been there for about sort of 4 or 5 years now. And it's been a really interesting 4 or 5 years that I've been there. When I first went into Scottish Government, we were just pulling together our first energy strategy. And since then, we've been working on a huge range of policy areas, thinking about the things that we can do within Scotland with the devolved powers that we have in Scottish Government, thinking of how we need to work with UK-based institutions like Ofgem, like the electricity sector, and with UK government to get an energy system that works for Scotland's ambitions. So what I'm going to try and do over the next 15 minutes or so is give you a bit of a whirlwind tour of Scotland's energy system. And I'm going to try and do that to highlight some of the areas where technological development and the sort of work that the ETP does will be really important. It's a big area, and as Stephen Mark said, huge task decarbonising the whole energy system. But it is the task that we've set ourselves to do in Scotland and to do by 2045, along with our wider economy. So start by asking this question: what is the role of the energy system? And I think this is a question that everyone involved in the system needs to ask themselves. We need to think what we're trying to do with this huge piece of infrastructure that we have in Scotland, in the UK, and in the world. Obviously, an energy system is about delivering energy to meet needs of citizens, of businesses, and really, the aim over the past century or more has been about doing that in a way that is affordable and reliable. Over the past 20 years or so, the importance of doing so in a way that is sustainable has grown, so that we get to today where probably the narrative about energy system change is about decarbonisation. And I'm going to focus on that quite a lot in this presentation, on what we're doing in Scotland to decarbonise our energy system. But it's also important to remember that that is not the only thing that we are trying to get our energy system to help us with. Yes, we want a net zero energy system, but we want a net zero energy system in order that we in Scotland a good place to live, a place that provides opportunities for everyone, provides a good quality of living, provides opportunities no matter where you are, and meets this kind of much bigger set of objectives that a society has. What I've put up on the screen just now is just a snapshot of a couple of things that influence that. On one side, you've got that update to our climate change plan that we published last year, and more about that in a minute. Next up, you've got a document called our Just Transition response. So Just Transition is a really important narrative that is informing energy system change at the moment, particularly in Scotland. And it's about making sure that the transition to a net zero economy is that takes everyone with it and provides those opportunities for everyone in all places in Scotland. The next diagram that I've got, the document that I've got there is the Fuel Poverty Act, which was passed in the Scottish Parliament back in 2019. And this says that we need to eradicate fuel poverty from Scotland as far as is practical by 2040. And it's that specific quantitative numbers there about the pathway to achieving that. Fuel poverty is people who have a very large fraction of their income spent on energy to heat their houses and to run their appliances. And removing that is an objective of our energy system. And last of all, in a diagram that you're not going to be able to read all the details of, is that I suppose the biggest articulation of Scotland's aims and objectives of what Scottish government is trying to do with the country. And energy plays into all the elements of that, not just the one mentioned just now. So let's focus in for a minute on that climate change question and the update to our climate change plan that we published last year. By 2045, Scotland is aiming to be net zero. That means our net carbon emissions, our net greenhouse gas emissions will be zero. And the climate change plan update lays out the first part of that pathway up to 2032. And there are some huge reductions in carbon emissions and greenhouse gas emissions that we need to see between now and 2032, not much more than 10 years away. For example, and I'll highlight just a couple of the energy sectors that are important. In Scotland, we've decarbonised electricity massively over the last decade. It's now, I think, at about 43 per kilowatt hour of carbon associated with the electricity we generate in Scotland. That's down from about 300 to 400, much more than a decade ago. But we now need to finish the job. And by 2020, to have a zero carbon electricity system. And actually, when you get down to it, quite a lot of the issues associated with that last step are some of the hardest. Buildings, so heating our buildings, this is another massive one. Between 2020 and 2032, we need to reduce the emissions associated with heating our buildings by 2/3. So from today to the end of this plan, 2/3. So that's going to involve decarbonising, around half or more than half of our buildings completely, as well as reducing the demand in the rest of them through things like energy measures. Transport's another one. We need to knock off 1/3 of the emissions by 2032 compared with the start of this. And lastly, to highlight industry. So industry itself and the emissions that come from industry need to reduce again by about 1/3 compared with today by the end of this pathway. And on top of that, we are proposing that we will bring forward projects, or we will help projects come forward in Scotland to deliver negative emissions of a substantial quantity by 2032 as well. So these are the kind of envelopes which we need to see progress on in Scotland over the next decade. The final point is just to circle back round to that initial slide. It's about delivering decarbonisation, but it's not just about delivering it. It's about how it's delivered. We need to think about the economic consequences, the opportunities developed in Scotland, the potential for supply chain and economic growth, the way that this works in the islands in the north of Scotland, as well as in the urban areas in the central belt. We need to think about transition industries in the northeast of Scotland currently reliant heavily on oil and gas, fossil fuels, to part of that net zero energy system. So there's lots of other things there to think about, as well as the decarbonisation. So the main sort of thrust for the next kind of 5, 6, 7 minutes is this whistle-stop tour through the whole energy system of Scotland. Now, what I've put up on the screen here is a map that we've been developing over the past few months in Scottish Government to show everything in the energy system. Quite often when I speak to groups about the whole system, people tend to focus on bits of the system. So, for example, when I speak to people who work in the electricity sector, they tend to think that when I talk about whole system, I mean the whole electricity system. But actually, it's much, much more complicated than that. And we have many groups of infrastructure that are interacting together in important ways. So this map, and you'll be able to access this on the slides afterwards, gives an overview of all the major pieces of infrastructure within Scotland's energy system. It won't include everything, because there'll be small things that are missed off that maybe we can't fit, you know, we can't over cram things onto the map, but hopefully it shows all the main points. The other thing it shows is the interactions, and I'll show you a couple of examples of that in a second. But I'm hoping that what it does is it gives you an indication of all the things we need to think about in terms of decarbonising energy. I'm also hoping that a map like this can help spark some discussions. And I'm very keen that we as a government get to hear what the outcomes of those discussions are. So let's look at the different bits of the map. So I'll start off by mentioning the electricity system. This is something where technology development has made huge strides over the last couple of decades. When I started in this field in 2009, were maybe a couple of megawatts maximum, and quite a lot of people were saying at the time that we could never get wind turbines bigger than maybe 4, maybe 5 megawatts. We're now up into double figures with some of the designs of wind turbines for the offshore environment. That's a huge technological change. So what we can see on this map over towards the left-hand side is the different ways that we can generate electricity. We can do it from a range of renewable sources, which kind of come down the vertical arm of that line. And then as we go across the middle, we see that there are other ways of generating electricity, like nuclear power. Currently, we don't expect that to play a part in Scotland's energy system directly in the 20s. But we do know that nuclear power will be part of the English energy system. Power stations, possibly hydrogen power stations there, the development of more biomass, potentially with carbon capture and storage connected to it. And then as we move across to the middle section, we've got those big pieces of infrastructure where there's huge opportunities to develop the way they operate. The storage of electricity, pump storage, batteries, for example, the networks, the transmission network and the distribution network. And finally, towards the right-hand side, we've got different uses of electricity. In the middle, the sort of typical domestic and commercial uses. Towards the top, new transport demands for electricity. And down the bottom, heat and then industrial uses for electricity. The next one to look at is the oil part of our energy system, which today is a really important part of our energy system. But it's a big fossil fuel part of our energy system. You can see towards the top, you've got the offshore infrastructure out in the North Sea. Then you've got refining in the middle, and out towards the right-hand side, different ways in which petroleum are used. Now, we're going to have to draw back from those over the next couple of decades in order to meet net zero. And one of the things that we need to think about is how we choreograph that change. So it's no good just drawing back on one type of energy without putting in place alternatives. And that's what we're going to need to do, particularly in the case of petroleum in the transport sector. We're going to be replacing petroleum demand with hydrogen or electricity. And it's really important that we coordinate how that change happens. The next line I was going to show you was the natural gas line. This is similar to the petroleum line in that we have lots of infrastructure off the North Sea for the extraction of natural gas. And currently that's mainly delivered through our networks to be burned for heat. In the future, there's new opportunities, particularly in combination with carbon capture and storage. So, for example, we can start making blue hydrogen through a process called steam methane reformation or related technologies there. And I think there's a really good opportunity for really big technological development in that space. We've got opportunities to blend in with our natural gas or replace natural gas in our pipelines across the country, either with biomethane or with hydrogen in the future. Hydrogen is a new infrastructure group, and there's a huge amount of development that needs to happen in that space. We've got different ways of producing hydrogen. We can produce it from electrolysis combined with renewable power. We can produce it from steam methane reformation. We can produce it from biomass that's gasified. We can combine these processes with CCS. All of these are opportunities to decarbonize bits of the energy system. But there's big kind of technology development opportunities associated with those. Bioenergy is an important part of the energy system. Today, we use about 6 terawatt hours of energy in the form of bioenergy in Scotland. In future, we may use substantially more. Combined with CCS, we have an opportunity for that to be negative carbon over the life cycle of the biomass that goes into that. And that's one of the key areas where we can get these negative emissions that we need for our climate change plan. This shows that there's huge links to things like land use, sustainable global trades in bioenergy that we need to think carefully through, and technologies that we need to develop, such as biomass gasification, if we are to achieve our objective. I think this is the final one that I wanted to show, which is over towards the right-hand side, which is we have to develop heat networks at scale. We actually have a legislation in the Scottish Parliament which requires us now to deliver, I think it's 6 terawatt hours of heat from heat networks by 2030. And that's there are heat networks already, but there's a big expansion that needs to happen there. And we need to link those networks with ways to produce heat renewably. So big, large-scale heat pumps, hydrogen, potentially biomass combustion potentially. And down at the bottom is a kind of a related set of infrastructure, which is the infrastructure of our buildings themselves. And we've estimated that there's about £33 billion needs to be invested in Scotland's building stock by 2030 to meet that heating buildings envelope that I showed you earlier. There's big opportunities there about how we link things together, how we coordinate the delivery of heat and the way that that is then used within. So that's a kind of quick overview of the energy system. Although there's one more line actually that I haven't mentioned, which is the carbon capture line. It's come into quite a few of the other things that we've said there, but running around the energy system in the future is the potential for this carbon capture and storage infrastructure. Now, that is something that is another new infrastructure group along with hydrogen that we haven't had before, and we are going to have to build from scratch. And it's going to be really important to coordinate how that develops with other changes in the system. Just checking how long I've got, not too long actually. So let me just try and finish up quite quickly. I wanted to finish with 4 big challenges for the energy system. So the first one is reliability, resilience and security of supply. Making sure we do that in a zero carbon energy system is really important. And we worked on a really good project with Scottish Power Renewables, which demonstrated just last year the ability of a wind farm to black start the electricity system. Now, that's the first time anywhere in the world that that has been done. It's a great first for Scotland, and it shows the sort of technology development that we need to see. Wind turbines in the future need to not just deliver megawatt hours of zero carbon energy, but also provide these services that the energy system needs as a whole to be reliable, resilient, and secure. The second one is we need to think about our technology in ways that supports the whole system. I think sometimes I have discussions with technologists who talk about, a technology solution to meet a business need. And that's, I understand how the market tends to work. But increasingly, we need people who are not just about meeting the current market need, but how that technology will work in a system in 2045, where we have a very different energy system overall. We also need to think about concrete ways to change. And there was a really good example in the petrol shortages a couple of weeks or months ago. In the UK, we have a huge amount of petroleum held as reserves. We have to hold 90 days usage of petroleum in the country equivalent, and that's, I think, under international requirements. But at the time, we had issues about distributing that because of lorry drivers, and then we had people responding to the potential that there might be a shortage. I would like people to think really concretely about how technology can help us to change that, so that in the future, when things like that happen, people might behave in slightly different ways that supports the whole system. And my last thing was zero carbon energy storage. Today, we rely hugely on fossil fuels for energy storage in our energy system. And the diagram on the right-hand side shows this. We rely heavily on coal stocks, crude oil, natural gas, and petroleum stocks. We still have huge amounts of energy stored in fuel tanks, in our cars, or under filling stations. And at the top, the last three items at the top are the energy stores linked to our electricity system. So whilst we talk about energy storage quite often in the electricity context, we really need to think about what we're doing about decarbonising the rest of our energy storage for the energy system. That's me done. Thank you for your time. I've left you there with a couple of suggestions for things I would like to see people doing over the next few years as we go through. Think about your technology as a whole system issue. Recognize its limitations as well as identifying its benefits and where it needs to work with other technologies. Think about your technology in terms of all the outcomes that our energy system aims to achieve that I mentioned earlier. And speak to policymakers. As technology developers, it's really important you come and speak to us and that you contribute to the debate. Thank you very much.
And that was great, a great overview. Again, added to our expert knowledge that we have already. I actually have a time for a question from Natasha. She's saying, Simon, this is an extremely helpful energy systems map. Thank you. Would be great to take this for input into the members of the lesson, Local Energy System Scottish Industry Network. What do you think about that?
Absolutely. So I've been to one of the lesson groups in the past. And it's a great forum for bringing together local energy contributors. That map arrived in my inbox from the designer yesterday. So this is its first outing, and I did just spot a typo actually in it that I'll need to go back and get them to correct. So you guys are seeing it first actually, but we will be planning to use that as part of our engagement and discussion pack over the next wee while.
Now, it does make understanding the connection between all those components a lot easier than otherwise would be, that's for sure. Just one thing from me then before you go, Simon, is this idea about actually having to have energy storage. I mean, will we ever get to a point where, in fact, energy is created and consumed or created at the point of use?
I don't think so. I mean, and in some ways, if you were to do that, you wouldn't need the energy system because you would just be exactly at the place and time that you needed it. The energy system is about taking it from where it's available to and when it's needed. And in the past, we've relied on these fossil fuels to hold on to that energy until we need it. Electricity is a really challenging energy vector to store energy on. And no matter what we do with pump storage and electrical batteries, I think we're never going to manage to kind of replace those fossil fuel things. We've got an opportunity with something like hydrogen. That is something which could act like natural gas as a relatively large store. We will reduce the amount of energy we need to store considerably, because, for example, if you think about electric vehicles, they go a lot further per kilowatt hour than a petrol or diesel vehicle of the same size, and therefore you don't need to store as much energy to allow, you know, so that it has a store to drive 200, 300, 400 miles. But I do think this is a big issue, and it's a kind of an under the water issue. It's something that not enough people are thinking and talking about at the moment.
Okay, in fact, just one more question if you've got. We'll shoehorn it in since it was asked. Liam, thank you very much for your question. He said there wasn't too much mention of solar in your talk. I wonder what your thoughts are around solar in Scotland.
So it is on the map. It is a source of electrical energy. We have quite a lot of rooftop solar in, and we have a scale solar farms. I do think it's got a place in Scotland, and there are opportunities that it works well with wind power in providing energy at some times, whilst wind isn't available, for example. But I think that's one of the things that we need to think about. One of the issues with solar, and this is true for wind as well, is it's never available at peak demand. So, sorry, wind is sometimes available at times of peak demand when it's cold and windy in the winter, but solar is never available at times of peak demand when it's because that's at about 5 p.m. on a January evening. So solar has a place to play, but that's one of these limitations about a technology that is really important to then think about. So you take solar and you think, okay, what can it do? How can it combine with other things to help us on the resilience issue? And the obvious thing there is energy storage, maybe potential to combine with electrolysis to go into hydrogen for storage, for example. So I do think there's a role for it. And I think that there is a real opportunity to think how it fits into the system.
Simon, right, we'll leave it there. So thanks a lot for participating, Simon. I'll see you soon.
Yeah, thanks. Cheers, and thanks for all the questions.
Great. Very good. Okay, thank you. Right, very good. Okay, just to remind you that we still have the poll going live to do with where we think that we should put our investment and our efforts, which sector of the energy system. So I'm not quite sure whether they're going to show it or maybe show that later. But anyway, that is definitely something. So please look at that. It's in the portal. So answer it somewhere. So our next presenter is Maja Frost. So Maja is, in fact, is an ETP alumnus. She was funded through the ETP, and there she is. Hello, Maja. Long time no see. How are you?
Yes, hello. Yes, it's been a very long time. I don't think I've seen you since before the pandemic. So.
Oh, yes, certainly, yes. So we brought some students over to Levenmouth, didn't we, to have a look at your system over there and the large kind of offshore wind turbine. Yes. So Maja, so now where are you speaking from now, Maja?
I am currently in the south of Sweden.
South of Sweden, perfect. I mean, isn't this great? Fantastic. Okay, so in that case, I'll leave it over to you.
Yes. Okay. Well, hello everyone. So my name is Maja, and I just completed a PhD, also funded by ETP, which is focusing on techno-economic analysis of local hydrogen production for energy storage and services. Where I worked with University of Edinburgh, Bright Green Hydrogen, and ETP, where my supervisors were Dimitri Mignard, David Hogg from Bright Green Hydrogen, and Gareth Harrison and Stuart Galloway. So I'm just going to start with going into what Bright Green Hydrogen was and the Levenmouth Community Energy Project. I'm then going to carry on to talk about my role in the project and some of my findings, and then what I do now after my PhD. So, Bright Green Hydrogen is based in Methil in Fife, and they were launched in 2014, where the main goal for them was to showcase hydrogen's energy storage, and also looking into how to bring the hydrogen project further, because they had before that successfully completed a hydrogen project, which was a project that looked into having wind energy from a 750 kilowatt wind turbine, using that to create hydrogen and as energy storage for one building. And they wanted to bring this further by using different types of renewable energy, having more buildings and more demand, and also different uses for hydrogen. So not just energy storage for buildings and using fuel cell. So that's what then brought them to the Leave and Maja Community Energy Project, which I am going to refer to as LSEP going forward. And that basically went to demonstrate. It was a demonstration project looking into hydrogen's different uses. So the other use that then brought in was looking at fuel for vehicles. So with that, they increased the renewable energy generation. So they added solar panels, both ground and PV solar. So it went into a total of 910 kilowatts of renewable energy. And then they had 8 buildings instead of just one, all different types of business buildings. And they worked with Toshiba for to include their hydrogen energy management system, a smart grid control. And then they had one big electrolyzer that was 250 kilowatts. That was called the H45. So whenever I mention the H45, it's the main electrolyzer they had on site. And 100 kilowatt fuel cell, that was for the energy storage system, and with a 45 kilogram hydrogen storage tank. That was roughly 1,400 kilowatt hours of energy stored. And then for the refuelers, they had 2 different refuelers, one PEM and one alkaline, both rated at 10 kilograms per day. And both had 60 kilowatt electrolyzers in them, but 2 different technologies, so they could actually compare the 2. And this became operational in 2017. And basically, for me, this meant looking into the whole system and start gathering data. So the Leave and Maja Community Energy Project, because when they started this project, they wanted to look into how to use the vehicles also. The main focus in terms of the energy strategy was first having renewable energy feeding into the vehicle refuelers. So the green line is the flow of energy that was showing the energy strategy of the system. So we have the renewable energy coming in and to the hydrogen refuelers, and then that whatever was left over would go into the hydrogen balancing system. So the H45 and the fuel cell as energy storage for the buildings, and then whatever was left over for the renewable energy that went into the microgrid. And so here's just basically all the buildings that were included. And then whatever was left over was then exported to the supporting grid. And then there was also a connection from the main grid to the buildings. So that's how it looked like as a diagram. This is what it looked like in reality. So we have the wind turbine, all the different buildings, and the roof PV and the ground PV. Everything can be seen here, apart from one of the buildings, that's the boat club, which is just a bit too far out. So with all this information, I then started looking into producing a techno-economic model using Simulink and looking at all the data loggings and learnings from the site. So not just what they would be expecting and reading about for hydrogen performance, but actually what they were seeing as everything was operating, how to include that in the best possible way in the model to make it as realistic as possible for these type of systems. And with that, I started exploring different layouts, capacities, usages, scenarios, and integration of other technologies to find optimal use for hydrogen. And basically, I wanted to answer, at least look into the question of small-scale hydrogen systems. What are the conditions and configurations that can make them economically viable and performant? Now, there were just so many different things to consider in this and these type of systems with different users. which led to quite a lot of simulations, which are all summarized here. And definitely not all the simulations that could have been made for this. I thought of so many more that just I did not have time, but they were grouped basically. So I looked into different control strategies for the H45. I then looked into trying to improve the energy storage system for the buildings by increasing the storage available and only having energy storage for buildings and not vehicles. I then went into the third group of simulations, which was focusing on the refuelers by increasing the refueler storage, maybe looking into could we have just one refueler instead of two, and could that meet the vehicle demand? And then looking into the types of refuelers, could we change the technologies and how would that impact it? Then I went on to another group of simulations, which was trying to balance the different capacities of renewable energy coming in and the rating of the H45 and the energy storage for the buildings, and trying to balance them to see was it a better way to do it. And then I created a lithium-ion battery model into the system in my Simulink model and started including that to see how could that work with the hydrogen system to potentially make it work better, both for hot standby support and for improving hydrogen production, and also actually could it perform better than the H45. So you had the lithium-ion battery for energy storage for buildings, and then you had hydrogen for vehicles. So yes, basically these were the simulations, and I did them in different types of vehicle demand, which was low demand, medium demand, and high demand, which is what LD, MD, and HD stands for in the table. So I can't go into all the results because that would go on for a very long time, but I'm going to talk about some of the highlights and some different outputs that came out of that. So the first thing I did when I was looking at the data for the main electrolyzer, the H45, my supervisor and I, when we started looking into the different models that could be used for this, it was found that none of the models actually really fit with the data we had available, and also how it was performing in terms of the renewable energy coming in and the hydrogen coming out, because we found that it was not as linear as some models were showing. So instead, we started developing a new model that was then published as well, using real-world data from the H45, where a semi-empirical model was produced, using the key data from power usage and hydrogen produced, and also some general product specifications of the electrolyzer. So it was found that this was a lot more accurate at low load than commonly used linear models, which was very important for me to include, because with wind energy, the main electrolyzer was very often having to operate at low load, especially as it was after the refuelers in the energy strategy. So obviously the refuelers were using quite a lot of renewable energy before it was then available for the H45. So it was quite important to make the most of that and actually show that performance a lot better, and how it was working a lot more realistically. So with that, the key outputs from this was a better representation at energy consumption and hydrogen production at low load. And this was very frequent for this system at LSEP. And the data showed also the impact of low load operation and how it can result in significantly higher energy usage than predicted. So this model, along with the control strategy work, helped reduce this quite a lot. And in terms of that, I'll go on to the next slide, where when looking at all the data, so this is data from the H45 as it was working at LSEP. And it was when I started looking into the data and how it was performing, when it was sitting in hot standby or cold standby, and when it was off completely, and when it was actually producing, it was found that it was very often sitting in hot standby for a very long time. And that was because of the control strategy that was there and for that electrolyzer. But it meant that over time, it would use quite a lot of power without any output, which wasn't very economical for the system. So with that, I created two different energy controls for it in Simulink. One was reflecting exactly how it would work at bright green hydrogen. And another one was an alternative one where it looked a lot more at the weather forecast data coming in, and also comparing it with the actual weather data that it was seeing, and also trying to compare it with the how much energy was being used by the refuelers, so how much was actually available for the electrolyzer, so it could make better decisions. So with that, we had a simple and an advanced control strategy for the H45, which resulted into this. So the ACH, so that's short for the advanced control strategy. With that, the H45 needed 68.5, 61.6, and 58.5% less energy from the supporting grid, with low, medium, and high vehicle demand, respectively, which was fantastic. And that was obviously something then I started incorporating into the model and having the advanced control strategy instead of the one that was at the outset. And the only impact on it, it was actually quite small, was it had a very small reduced hydrogen production, because it was less than 4% less hydrogen produced with all scenarios of vehicle demand. So with that, after doing those simulations, I basically kept the advanced control system for all the other simulations. And this is one of the example of some areas I looked into where it was quite difficult to make all the parts of the system happy when you have so many different parts. So I had to explore different areas to see what made more sense and what was more helped it perform both technically better, but also then looking at the economic side. So the system size and energy strategy meant that only that one end use was always prioritized over the other, which meant that was always the main part that was doing really well. Whereas the other ones, you could only improve them so much, but they would still be a bit compromised. And so I tried to improve, for example, the energy storage system for the buildings as much as possible, but unless you had no vehicle demand at all, it was still a little compromised, basically. And so you could see that in these graphs. But what's also interesting is the percentage of total buildings demand that was met by renewables and fuel cell. That still doesn't reach 100% with no vehicle demand. So even though I was trying to make the system sometimes as independent as possible, it was still not becoming quite independent, and usually meant that a lot of the items became quite oversized for what it needed to be. And that obviously then increases a lot of costs with not a lot of extra output. So overall, it was better to focus on more on the balancing the system overall and avoid oversizing of the electrolyzer, and focus more on the hydrogen storage available, and not aim to achieve an independent system, but just try to actually balance it better and just be okay with using energy from the grid. So some items I started looking into was also the electrolyzer capacity factor, because obviously with the electrolyzer being such a big investment, you want to make sure it's used a lot. And the highest capacity factor for this type of setting and sizing of the components was 25%, and this was for a 125 kilowatt electrolyzer and 90 kilograms of hydrogen storage. Now that is an electrolyzer that was half the size of the H45 and also doubled the hydrogen storage. The lowest was 13%, which is very low, and that was for 200 kilowatt PV instead of 160 kilowatt PV. Now, the interesting part with that was you would assume more solar energy coming in, some more renewable energy would be great for the electrolyzer, but it actually just was a good benefit for the refuelers, because the refuelers just became more active and the vehicles then had a lot more of their demand met. But it actually ended up having a negative impact then on the electrolyzer coming up, the main electrolyzer coming after that. So yeah, that was quite interesting. And then I went into cost analysis, where I used the real costs on the site for 2017, and I talked to the people who had been working on it to get estimates on 2020 costs, and I compared that to see the trend. I looked at and then into the MPV of the system for different electricity and hydrogen selling and buying prices. For all the cost analysis, I considered 4 different pricing scenarios: one for a complete energy system being built, one for only a hydrogen system being built for an existing renewable energy system, and then a complete system was built where the capex was covered by funding, and then a hydrogen system was being built where renewable energy had to be bought locally. So with that, some of my conclusions. A system like LSEP would have benefited from a smaller electrolyzer and more storage, and as was seen with the capacity factor, and also from the economic side of it later. Having more than one end use meant that one part of the project was always compromised. So for small systems, that was usually not worth it. It probably would have been better than to have a bigger system working on this. Even though only a few simulations were able to find a positive MPV, there were large cost improvements for 2017 versus 2020 costs, which showed quite a bright future for hydrogen because of the difference I have made in 3 years. And technology improvements such as stack durability and material costs were found to be, it would make a very big difference in the future for the system's performance when I was considering that in the costing side. So where has my PhD led me? So I'm currently working as a consultant at DNV in the Energy Systems Group, more specifically in the Energy Markets and Strategy team, where the team works with helping companies deal with a changing energy landscape, where we work on market analytics and strategy, and market and generation modeling, market design and network access, and market integration and regional market. So I specifically work on a wide range of hydrogen projects, from market landscape to analyzing carbon footprint of hydrogen technologies and things like that. I also work on carbon footprint and life cycle assessment on other technologies, and also many other projects within sustainability, energy, and carbon neutral in general. So anything regarding that, I tend to work on. So it's definitely very varied. Yeah, so are there any questions?
Right, well, thank you very much, Maja, for that. So I do have a question, actually, and I'm going to thank you, Stephanie, for asking this. So Maja, you probably read it in the discussion forum too, but Stephanie asks, how well can hydrogen electrolyzers integrate with the variable nature of wind energy if generating directly from wind turbines?
So that depends a little bit on the technology. So PEM works a lot better with variable input than alkaline, for example. But also what you can sometimes do is, if you have a combination of different renewable energies, so not just wind, then the other types of renewable energy can help smoothen it out a little bit as well. So yeah, that answers your question.
Thank you. And yes, I have a question for you. So how did you find the transition from being a student to actually the world of work, and obviously translation off to Sweden as well?
Yeah, it was quite interesting. I think especially during a pandemic, I met all my colleagues online for a long time before meeting them in person. Most of my colleagues are in Norway, so it took quite a long time before we could meet. And yeah, it was quite interesting. It's very different because it was not just focusing on one project anymore, but I usually have 3 or 4 projects going on at the same time, and they all get done within 1 month or 2 months, and then it's on to the next one. So it's very fast paced.
Slightly different to doing a PhD.
Yeah, it's very different to a PhD when you focus on one project for a few years. So.
Yeah, exactly. Yeah, that's right. Okay.
But it's really good fun, and usually a lot of the projects can be quite related to one another in many ways. So you learn from one project, it still helps you on with the next one. So yeah, it's good fun.
Okay. Yeah. Yes, I would imagine. Just one further question is from Syra. Hello, Syra. What advice would you give to students to help keep them focused on their academic work?
I would say just have a plan what you want to do afterwards, and keep on thinking about that and making sure that what you're doing is leading to that.
Great, very good advice. Okay, then Maja, well, thank you very much for joining us today. I hope all goes well for you there in Sweden.
Yeah, thank you.
Okay, cheers. Right, very good. No, that's very interesting. So thank you very much. So all alumni are welcome back, as you know, to ETP Annual Conference, and thank you to Maja Frost for that. Just before we go on to Gerry, Jose, can you put up the poll results? Is that possible to do that? I hope I haven't just suddenly thrown that at you and you're going, no, anything but poll results. I can see by the face that you are making. So this is the poll which asked you, so we've got an interesting, here we go, excellent. So this is carried over from earlier, and unfortunately the one that you can't see at the bottom, I think is, I don't know, I can't remember what that is, but actually it's for some reason in this particular poll, no, still can't see that, but anyway, it's down there and it's one bit higher then. So Jose is throwing his hands up in, okay, never mind. So there's the break. You can obviously see energy efficiency in buildings is still popular, but the one underneath that, whatever it is, in fact, I can tell you what it is because I should be able to read it myself, is actually heat energy. So heat energy. So that's the #1 in the poll this afternoon. Excellent. Right, here we go. Back to the present and next on stage, and finally, to round off a fantastic day, welcome Gerry Agnew, who's the director of the Hydrogen Accelerator. Welcome, Gerry. And very interested to hear about what's happening with the Hydrogen Accelerator and maybe Gerry's views on hydrogen. So over to you, Gerry.
Thanks very much, and thanks very much for the opportunity to speak today. It's much appreciated. In this presentation, I want to introduce you to the Hydrogen Accelerator. It's possible you may have some familiarity with it at some level, but it'd be nice to see more of it, and explain how it ties in with the deployment of hydrogen and the economic benefits of hydrogen in Scotland. And finally, link it to some possible opportunities for the ETP community and how they could engage with it. And apologies if I'm a little bit slightly clunky. I have to use my phone for my speaker notes because this setup is slightly changed. Some upgrade somewhere has taken it to a new level and left me behind, so apologies for that. Okay, so I'll start with a bit of context setting. A very important observation that was made by MSP Rosanna Cunningham in 2019. There is a global climate emergency. The evidence is irrefutable, the science is clear, and people have been clear that they expect action. That's the context in which the Hydrogen Accelerator has been formed and operates, and it drives much of what we do. Okay, so start by introducing the mission of the Hydrogen Accelerator. I'll say a little bit more about how it's structured and who funds it in a moment, in a couple of slides on. But basically, it's there to facilitate the realisation of Scotland's hydrogen future, basically provide access to various expertise and support, help coordinate in various things that are going on in Scotland, and as part of that, play a key role in delivering the decarbonisation of Scotland. Much of what we do hovers around those 4 items: technology assessment, matchmaking, optimization and standardization, outreach and communications. So we are very much an accelerator that's about information dissemination, collaboration, making it happen. We're not an investment accelerator or something like that. Okay, so with that, I'd like to talk about our key stakeholders. Firstly, I need to say that it's a collaborative activity between University of St Andrews, where the main base is, and University of Strathclyde. And of course, with those two institutions come their satellite, highly relevant technical institutions, the PNDC at Strathclyde, engaging with all the issues to do with power networks, and now drives and transport related power electronics and machines activity. And on the University of St Andrews side, you have the engagement with the St Andrews Eden campus, which is all about decarbonisation, everything from pilot manufacture of batteries through to power to liquids type research. And then the sizes of the boxes are in no way related to the strengths of the relationships. But first and foremost, I have to mention Transport Scotland, who fund the Hydrogen Accelerator. And then, of course, we're engaged with all the key stakeholders around the patch: industry, academic experts, research institutions, and, of course, in large part, the public sector, who are actually trying to reach out and make this happen, either at local authority level or within government departments or other parts of the Scottish government ecosystem. Okay, and then on to the specific activities to help anchor it to the reality of what we do. We're all about things like identifying and developing Scottish supply chain, sharing learning and experience, making sure that projects that go on in Scotland build on each other. We don't just go around in circles repeating our mistakes. Identifying overlaps in existing projects and helping make those happen in a better way. Helping develop risk management strategies, people, and then, as always with anything that's to do with energy, promote health and safety. Hydrogen is no less health and safety oriented than any other area, and obviously with any fuel you want to be super safe. And then finally, we help people identify funding. We don't provide funding, so if you're thinking of knocking on our door wanting some money, all we can do is help point you to the right people who can provide that money. Okay, moving on then to the context of Scotland's decarbonisation targets. And you will already know, I'm sure, the general gist is Scotland is 5 years ahead of the rest of the UK on its path to net zero. And so consequently, we see the phasing out of public sector petrol and diesel vehicles in 2025, emission-free city centres 2030, and so on with cars and other things, all is 2035, and on a path to just be there that bit earlier, rightly enabled by the fantastic renewables infrastructure that's in Scotland and the will and agility of a government that can move quickly. So moving on from there, we'll talk about green hydrogen deployment and the kind of timeline. A number of major projects are already out there and are happening, and we're transitioning others into reality. The most current of those that are transitioning is the Whiteley 20 megawatt green hydrogen farm, for which the funding was recently confirmed at 9.4 million. There is the Scottish Government Draft Hydrogen Action Plan, which came out with COP26. And then we have other projects, some of which you will have heard about already in this conference. The one that I'll say a bit more about in the near term is the zero emission train. And then some of the other projects that you see sprinkled across there, we have significant involvement in, and I'll talk to those as well. Okay, and then moving on to the next slide. Firstly, I just want to make the case for hydrogen. We need all of the energy storage means that will allow us to deploy our renewables into the applications where they're needed. If you do a classic Ragone plot of just the energy and power of the actual stored energy required for emission, and you plot it all out, it's a logarithmic plot. You've got energy density in watt hours per kilo up the y-axis, and across the bottom you've got power density. Nothing below any point in the graph can power something above it. You need enough energy to supply a mission. So essentially, the electric car there can be supplied by the capacity of batteries. However, a longer mission vehicle, and if you notice the diagonals on these Ragone plots are mission times. So an application that needed 10 hours worth of energy provision at this sort of significant hundreds of kilowatt scale, such as a long-term delivery of delivery vehicles, ferries, trains, starts to move well outside what batteries can deliver. That's not to say that we don't need batteries. You can't implement hydrogen vehicles without the different timescale storage of batteries and supercaps. So we need all of them, but we shouldn't be under any illusion. You can't power everything in a renewable world with supercaps and batteries. You're going to need hydrogen, and ultimately this plot can be extended to cover some of the other vectors such as ammonia and synthetic aviation fuels, which are needed for the most demanding, energy-dense, long-range missions. Okay, and with that then, I'll move on to discussing the fuel cell and hydrogen train aspect that I mentioned I was going to get to. So essentially, a key part of Scotland's decarbonisation strategy is its decarbonisation of rail. You could ask yourself, you know, rail is one of the lesser carbon footprint areas compared to some other sectors, but it's ripe with many important aspects. It has an ability to have great economic value. It can be tied in with modal shift about how you do transport. And actually, when you start to look at hydrogen the way Scotland is, as an enabler for economic development, as well as a solution to decarbonisation, you see that essentially the way you coordinate rail with other activities creates aggregation in demand and other things which help enable hydrogen. So very briefly, the rail network of Scotland is planned to be substantially electrified, and you see in red the routes which are either electrified already or planned for electrification. And then you see in yellow where that's not so straightforward, and indeed, in fact, for green, where almost certainly an alternative traction system such as hydrogen is absolutely necessary. So for now, we're focused on the green routes, the Far North Line and the West Scotland Line, and essentially those are the drivers in terms of deployment, but it's all about economic development and creating a next generation of employment and supply chain opportunities that hydrogen can enable. So talking in a little bit more detail, just a kind of overview, basically the project has revolved around converting a Class 314 train. It's a 40-year-old train designed to be powered off a 25 kV line. It's a bit of a museum piece, it has to be said. It has a thyristor drive train on it that we simply couldn't retain. We couldn't have made a stable coupling between an inverter and that drive. And instead, what we did was we tractioned it, which you wouldn't normally necessarily seek to do if you could avoid it, but actually it makes a lot of sense in this application. One of the key things about how it's been done is it's been done by a consortium who are also involved in decarbonisation of other vehicles. And it turns out that the A-Drive platform that's used for that has commonality between those different applications. So you're building a kind of knowledge infrastructure around how to do drive trains with hydrogen that has wider applicability. Already we have recruitment going on that's covering about 40 staff at Michelin Scotland Innovation Park, and all told, this has quite a large impact through all the other supply chain and partners, many of whom have significant Scottish footprint. And one of the most pleasing pictures is in the top right, first generation of Scotland's new hydrogen rail engineers, from technical professionals through to full engineered charters people working on hydrogen trains. Lovely to see, and it's the reality of this strategy playing out. In terms of progress, we basically hosted a demonstration during COP26, which was very well attended. Almost 400 people came over 5 days. It was actually 10 half days. We had a lot of the key staff there, and actually it was such good engagement. We kept there and continued to have very good conversations. And essentially, we met many of the stakeholders around rail in Scotland and around hydrogen, everything from public sector and universities through to rail driving unions and key stakeholders in rail and transport in Scotland. One of the nice things we saw was how the hardware had commonality. You can see the modules in the marquee at the top right there. You could actually see a real fuel cell if you hadn't seen one before. You could identify that it's exactly the same as the one on the refuse collection vehicle that's on the next slide. And you can also see there how it looks when deployed as a train. That picture on the right in the middle has got the hydrogen units installed. So one of the cars had its units taken out and put out there so you can have a look. The other one, you had it fully set up. And for instance, it was just lovely to see the union guys recognize it looks like a train. It's going to be something they can drive. It's something they've been consulted about, something that we're engaging the wider community about. The next phases are more about actually creating a demonstration that can actually be on the main line. We didn't want to jump to that. We wanted to focus on our main objectives of injecting capability into Scotland, building capability in Scotland, and pulling together threads of capability in Scotland, rather than just rushing to having a train running, and everyone diving on there to be seen and photographed with the First Minister. The real priority is to effect real change and achieve economic development while decarbonising. Okay, so moving on then, one of the things we do is help play a role in aggregating and creating hydrogen demand. Key to the economics of hydrogen is to make sure that you have the right demand to justify having a decent sized electrolyzer. The Whiteley wind farm project starts with 10 megawatts, it'll grow to 20. It's at that size that the cost starts to become really quite attractive and the economics come good. And so one of the things we do a lot is essentially trying to put people together into consortia to create coherent amounts of demand that then make the supply affordable. Moving on, I want to talk about other benefits of hydrogen. So as well as creating economic benefit in terms of jobs and so on, you can actually use it and tie it to operational efficiency. At Glasgow Council have a very sort of forward-looking fleet manager, Eric Stewart, with a very strong background from industry, and he's had this very, very bright idea of turning the change to these higher capital cost vehicles to actually make them more sweated assets. So essentially, the bin trucks in Glasgow will be doing two bin emptying emissions back to back, and then you can have a smaller fleet. And then the fact that the individual vehicles don't cost a little bit more than the conventional vehicles it comes out in the wash, and you get an all-round benefit, especially when you include the value of the environmental benefits of having taken out slow-running diesel engines that are moving slowly through the city as the bin trucks collect their refuse. So the overall benefit is what makes it clear that it's worth doing for Glasgow. And it's a very, very good exemplar of how to deploy hydrogen in a way that gets all-round benefit. Moving on, I want to talk about the Dundee double-decker buses. So this is another key project that the Hydrogen Accelerator has been involved in. It's about a fleet of 12 hydrogen buses and a large refueling station, 400 kilograms per day at Michelin Scotland's Innovation Park. That's more than that fleet needs, but it's the size that makes sense in terms of getting the cost down, and it will then feed into other hydrogen activities in that area. And essentially, we're building a cluster around the innovation that's going on at MSIP, and essentially making sure that we have a really big hydrogen content in that, as well as the other good things there on decarbonisation, such as batteries. On site, there are two 2-megawatt wind turbines, and there's potential for a larger solar array. And you can see one of the new buses down the bottom, but it's not yet converted. I'd like to move on to a project called Locate. Locate is a test bed. You can see the acronym there about low carbon transport. And essentially, its purpose is to de-risk a late stage validation of heavy duty vehicles. One of the things we've identified as key to hydrogen in Scotland is to align with vehicle opportunities that are not volume opportunities. If you're talking about volume car manufacture, there's no point in competing with Toyota or someone like that who already has a solution. Get on board, help them get into Scotland. What we want to do is create the niche opportunities, the refuse collection vehicles, the gritters, those sorts of fleet vehicles, forestry vehicles, and then on out into some of the larger fleet of 40-ton heavy duty road vehicles. And basically, in order to do that, we want to de-risk the mission at large scale, late stage validation. And so we're putting in a vehicle test bed that's specifically tuned to developing and de-risking those vehicles at late stage. It's part of a larger ecosystem, which you'll see on the next slide. What I would say, though, is that there's things you want specifically in a hydrogen battery vehicle hybrid configuration. You want to support the DC bus, so that if you have an unintended transient in the real mission, when you simulate it, you don't drop the bus and have to start the test all over again. You can gather data and do the de-risking more rapidly, avoid extended deployment of prototypes to de-risk fleet deployment. Quick slide on how that fits in with the ecosystem around de-risking these systems in Scotland. Well thought through. You have DER Scotland as a sort of overall umbrella here. Locate plays a role and is complementary to that. But even at full system size, you might find yourself wanting to go to PNDC to test a 1 megawatt machine for a marine environment. Altogether, between these different institutions, there is a fantastic de-risking ecosystem in Scotland that is already beginning to attract people into Scotland specifically because of that capability. And then getting towards the end here, I want to mention one final project that we're involved in that's just got started. It's called SHIFT, and it's about understanding the feasibility of using hydrogen in the very largest vehicles, especially in things like agriculture and forestry. And that project has got going and is starting to develop momentum. And again, it fits with this overall strategy of creating capability in Scotland, exploiting opportunities where Scotland can make a difference in terms of developing specific vehicles and solutions, and at the same time creating a kind of know-how and base and knowledge around hydrogen, which will happily gradually transition oil and gas talent into the hydrogen world and other areas where there's want to regenerate the job opportunities. Okay, the last thing I'm going to mention is the Hydrogen Action Plan and what its strategy is about. Not time here to get into the detail, but it breaks down into the sub pieces, the main objectives and missions of deploying hydrogen in Scotland. It's recently come out. I'd urge you to go and have a look at it. It's very coherent and it begins to break the problem down into manageable chunks. And then obviously with that, we have to recognize that by 2030, we're going to have 5 gigawatts of hydrogen around and being used, which is a fantastic objective to set to make it really happen in Scotland. Okay, and with that, I'd like to say thank you very much. And if any of you want to raise any questions about how we can help you, I've got 1 or 2 slides on that as appropriate, depending on what the question is. Thanks very much.
Very much there, Gerry. That was great, really interesting. It seems as though it's a program that could be replicated in other sectors and technologies. It's quite unusual to see a government actually taking a proactive role in hydrogen, like it maybe didn't in wind. But anyway, that's a different question. So I do have a question here in the discussion forum. I think you can read it yourself, but it says, from Lara, hello Lara again. Good afternoon, thank you for the presentation. Does the Hydrogen Accelerator have a role in engaging with local communities and civil society actors to inform technology recommendations, for instance?
Yeah, absolutely. Consultation, as it tends to be called, around local authorities, outreach with a slightly different spin on it when it's universities, is absolutely very much what we're about. Part of what we're doing with the Zero Emission Train is we're planning some runs, at least 8 operating days, where the train will run, and we'll bring in people from the local community. There's also a project that's been done with schools, specifically allowing people to, the children to work on they've got some fabulous Lego. I mean, all the grown-up engineers were fighting to get on it, with little fuel cells and all the gadgets, little cylinders. You could make yourself your own little hydrogen vehicle, and that was run as a schools challenge. Down fantastically, and in fact it's very likely to be deployed more widely. So absolutely, we are about listening to the community and about understanding what they want from hydrogen and making sure at the same time that they feel happy with it. Hydrogen is a when engineered properly, like any fuel, can be a fantastically safe way to get energy around, and that knowledge and know-how is out there.
Of course, because it's not as if hydrogen is new. It's been around for decades. It's just that we've decided not to focus on it. Suddenly, over the last 12 months, it's just suddenly blown up, if I might use that, hasn't it?
Floated up to the top. Maybe it's buoyed its way to the top, Stephen Mark. I think that's another way of looking at it. So, yeah, and it has to be said, as someone I've got more than 20 years experience of working with fuel cell systems. If you want a scary, more work with is natural gas. It packs far more energy into a little bit of leaked gas. So hydrogen, although it's got some sort of a reputation around it, I think it's got a lovely future. It's got fantastic buoyancy that helps disperse it, and the fact that you have zero emissions at point of use is fabulous.
And how do we compare in Scotland then with what's happening internationally in this area?
Yeah, well, yeah, the good news there is that Scotland's contribution as a smaller country is proportionately bigger. The great thing about Scotland is it's got fantastic renewable resources. And I have to be careful what I say here from a diplomacy point of view, but having dealt with funding regimes and governments all around the world, I spent a lot of time working with the US Department of Energy in the States. I've worked with LG in Korea. And essentially, I have to say Scotland is magical. It's one of those governments that's small, fleet of foot, and where people don't just move on every 2 years so that they don't know what they're talking about. And then suddenly, by the time they're beginning to understand the words, they're moving on to the next department. So Scotland can really punch above its weight. It's got fabulous renewable resources, which will almost certainly be a fantastic export opportunity in future. And although the actual figures don't compare with what's being spent in Germany, when you scale it for Scotland's size, it's good. It's going to punch above its weight.
Good, thank you very much. Actually, there's a question here on the discussion forum. So Lubika, hello Lubika. Talking about 5 gigawatts of H2 target by 2030, where would the H2 be coming from? Who would be the main suppliers or producers?
There's a number of companies who are keen to do that. It started out with people from the sort of conventional energy sector who want to do wind to hydrogen systems, if you like with Whiteley and Scottish Power and so on. On the other hand, you're now starting to see new entrants who are specifically looking to put projects together. They want to buy land. They want to put together consortia to build the electrolyzers, and they're looking to do power purchase agreements, preferably with local wind. So there's a number of different structurings to that, and that's what's beautiful about it, because it's a whole new opportunity for which there's more than one commercial solution. And it's nice to see that Scotland has kind of very good early deployment of those new models. I need to be a little bit careful what I say, because there's a couple of things that are going on that are not fully announced yet, but there's some really great examples of new small businesses in Scotland coming about it a different way and getting to do that. But that's an announcement that will come very soon.
Okay, that's great. In that case, I think we'll leave it there then, Gerry. Thank you very much for coming and talking to us. It's been very interesting. I'm sure some of our students will be following up with you afterwards, if that's okay.
Yeah, no problem. That'll be great. Thank you very much.
Cheers. Thank you. Right. So if we could share a screen, please, Jose, that would be great. So here we are. And I know everybody's just kind of waiting around for this. They're going, oh, I wish those old blokes would get on with it. So here we are at the prize session. So just to remind you, the kind of 2 sets of prizes, one for the posters and one for the presentations. So let's get on with it then. So we get first the winners of the ETP poster competition 2021. I'm afraid I don't have any music, but I'm sure Brian would. So first prize is Orestes Angelidis, University of Glasgow. Well done to you. So I believe that's £300. That will be winging its way to you at some point, I think. And this is Orestes' poster. I'm afraid it doesn't look very good on the stage, I don't think, but it seems okay from where I can see it. Good balance, laid out well. We understand what's going on here. So enjoy that one very much. Well done, Orestes. Thank you very much, Jose. Well done. Second prize is Lara Santos Ayon, University of Edinburgh. So well done, Lara. So I have to say, actually, this one did split the judges a bit, but anyway, it got second prize, and here you go. So you can probably understand why when you see it. So an interesting layout, not one that I've quite seen before. So well done for you, Lara. And thirdly, third prize, and I believe this is £100. The second prize was 200. And we have Paul Kerr at the University of Edinburgh, who I don't think is, I think maybe won this before, I don't know. Anyway, and this is Paul's. Again, very simple, laid out, very clear, easy to read, understand the science. Excellent, Paul. So just to remind you of the winners. So first prize, Orestes. Second prize, Lara. Third prize, Paul. So that's 300, 200, £100. So as you can expect, it's a life-changing quantities of money. Right, so well done to those three. Congratulations, and thank you for, above all, actually, for participating. I know this is a very busy time, and sometimes it's difficult to do this, but well done for you three. Yes, congratulations. Right, and here we come to the individual presenters. And at this point, there are 8 prizes, each of £100, because there were 8 sessions. So here we go. So best presenters at sessions. So one by one. First session, the transport, Katie Davis, University of Edinburgh. Offshore energy applications 1, Lubika Slavon, University of Edinburgh. Something going on there, isn't there? C1, energy conversion and storage, Ahmed Mohammed at Queen's University Belfast. Thank you for participating. Ahmed from all the way from across the sea over there. A2, energy policy, people and society, Benjamin Nunn at the University of Strathclyde. B2, offshore energy applications to James Cairns, University of Glasgow. And finally, for this session, C2, heat energy, Fiona Todd from the University of Edinburgh. And then finally, the last 2 from today's sessions, we have energy distribution and infrastructure, Agatha Williams-Kelly. Well done, Agatha. I know that you're a very good presenter, so well done from you. University of Edinburgh. Et finalement, we have Antoine Raguis from the Edinburgh Napier University. So I'm sure he's been up here before. So well done, all 8 of you. As you know, there will be some, I don't know how, any bank transfer out to you all. So well done from all of you for participating. Thank you very much. So closing remarks. First of all, thanks everybody for lasting this long. I can see there's still 31 of you on the call, so well done. It has been a particularly trying year, and I understand immediately after COP26, people were very busy. So thank you all for participating. I found it a particularly interesting couple of days. We had some great speakers, some great sessions. Just one thought I had, actually, I should have said after talking to Simon Gill earlier about solar. Of course, it shouldn't be called solar, it should be called light panels. Quite why we call them solar, I don't know. But anyway, that's it's another day. Anyway, so hope you're all well. Hope you all have a fantastic Christmas. And thank you for turning up. And thank you to everybody for making this happen behind the scenes, Amy, Jose, and also my back team as well. So thank you very much and goodbye.